then you did better than you thought.
Great.
Mr. Graham,
69 is better than that.
Hang on a minute. Let me get attendance and then we'll talk. Well, I'm getting attendance, ladies and gentlemen. Open up your computer and go to joinpd.com.
No, Mr. Graham, it's Friday.
I do know it's Friday. Thank you for reminding me. And then, just relax. I will get it.
That's why I wait for you.
Yeah. In the span of 1 minute.
Well, hello.
It opened it on one. No, my cup opened.
At least that was a twofer.
That's a good. That's
What's
a
the
good
matter?
deal. Oh no, my cup was good. There is no. I was just going right there. Next one. Because both of us are
14. 4.
So Wednesday and Thursday.
14. All right, ladies and gentlemen. Yesterday, I had the joy and pleasure of watching my son get his wisdom teeth taken out. So yep. And it is amazing what people say under anesthetic. It is absolutely amazing. I refused to videotape him, but my wife wasn't quite so nice, so she has some interesting things for him for later on in his life. He is going to be 18 in 1 month and 1 day. So, June 1st,
May
1 month and 1 day.
May 27th.
You're trolling. Why are you being a troll?
Oh no, it's a Friday.
See, that's what I'm saying. It's a Friday.
It's a Friday.
So that's okay to troll on Fridays?
I mean, you're gonna be loose. So
What does it mean to troll?
mess around. Have a great time.
Mess around. Have a great time. Okay. Alexa, grab something to write with in your periodic table.
And maybe a calculator.
Maybe a calculator if you can't subtract 2 numbers.
This brand. How old are you?
I never seen that.
I'm as old as my tongue and a little older than my teeth.
How old are you?
How old do you think I am? Oh, yeah. Let the bidding start.
Between 50 and 40.
No.
I'm assuming he's
I would say maybe try 60. Okay.
52.
No, seriously.
Because he's older than me. How old are you, Mr. How old are you? You're a little high, but only by a little bit. Hey, you're were you born in 1980? My mom's born in 1980.
Okay, so Kiana, where did we leave off?
I'm thinking 54.
You're thinking 54.
He's gonna hit you with the
Thinking 54.
You're halfway to 100. Sorry.
Your math teachers are now somewhere going, there's a tremble in the force. What?
No.
What?
I'm thinking 52, Mr. Brown.
Don't lie
Kiana, you hit it right on the head.
Really?
Really? Why would I lie? If I was going to lie, I'd tell you I'm 28.
Right.
So,
Faith hit mine almost on the head.
what'd you say, Faith?
I guess 43. Very close.
Okay. So,
you're 54.
yes.
You don't have faith.
You're 4 years older than my dad.
My
Yeah. Yes, probably.
If you look at
Wow.
if you look at my mom's age, actual age, so a lot of people say she's 30-some years old and she's like 46.
Okay. Okay.
She says
Well,
she
there are
looks
some
like
people
the
who look their age and some people who look older than it and
right.
some people who look younger than it. And I don't know where I fall on there. Last chance, ladies and gentlemen. Somebody left this periodic table the other day in here. If you want it, you can come up and grab it. If not, I will recycle it for you. Okay. Your quizzes, ladies and gentlemen, are graded. I haven't returned them yet. That's not you guys.
Say Mr. Brand never takes the day off, so I wondered where he was.
Well, here's the thing. I very rarely take a day off.
For real.
Normally it is because of my kids. But I do have 2 what are called personal days that I still have to use or I lose. So I will be taking a couple days off at some point in time. So.
Personal days?
Yes. That's what they let teachers have.
What happens if you don't take them?
You lose them.
They don't go on to next year.
No, they don't.
That's kind of.
They don't. So anyway, ladies and gentlemen, all right. The sub did leave me a good note. I asked her if she was sure she was in the right classroom because she said you guys were pretty good yesterday. So thank you for that. Showed you one more video about Chernobyl. We'll move on from there now. Again, I probably should start looking into more things on the reactor incident in Japan, but I just haven't been able to find good stuff on the internet for it yet. So maybe it'll turn out someday. Okay. When we left you on Wednesday, ladies and gentlemen, we were talking about the 3 types of nuclear decay. Alpha, beta, and gamma. And that's what we are going to do with our pair deck today, is we are going to review that. So hang on a second, and I will give you the pair deck code because I haven't gotten it yet. Hold on.
So is he doing better today, Mr. Brand?
I think so. He's planning on going to work today, so yes.
Hope you can talk more clearly. Hope your son can talk more clearly.
Yeah, he was able to talk real clear after the anesthetic wore off. He was a little sore last night. Had a dinner of pancakes, Jell-O, and ice cream. So, then why do you want an apple?
My dinner after my wisdom teeth was liquid mashed potatoes.
Yeah. I still have my wisdom teeth. I can't afford to lose any smarts.
My molars were getting fully developed because they were recently coming in recently.
Yep.
All my 4 molars.
Insincere ninjas.
Magically give insincere ninjas.
Yeah.
So who are they giving the insincere ninjas to?
Growth raisins, that's a give.
That's the question.
Probably raisins that aren't broke.
How do the raisins become broke though?
Well, they spend all their money.
On insincere ninjas. And they magically give them to not so broke raisins.
But are they that kind of broke, or are they broke in half? Broke.
I don't know. I heard it through the grapevine that it was their money, but I don't know.
You have a coin.
So
The grapevine. Okay.
I don't think Mr. Brand is doing that anymore.
It's 2024. It can be anything.
could be. All right, ladies and gentlemen, here we go. So today we're going to actually start balancing nuclear decays. In a minute, some of you did the assignment on Wednesday before we left where I asked you to find a type of decay that was alpha and beta and then a stable one. Some of you did not. We'll give you a few minutes to get that done, ladies and gentlemen. So, but we will get that in a little bit. And then we're going to show you how to actually balance off nuclear decays. I showed you what it looks like when you do them. We're going to show you how you can predict what is created, okay? And then there is a balancing nuclear decay worksheet here because it's good practice because you're going to be asked to do that on your test. Okay? So again, ladies and gentlemen, on tests and quizzes, they are there to say, okay, have you understood the stuff we've talked about this week? After your quiz yesterday, I would say for some of you that's an A, okay, because there were a lot of scores that were under 50%, okay? So again, ladies and gentlemen, it isn't so bad that you didn't know it on the quiz. What's bad is if you don't get it down and learn it before the test, okay? So keep that in mind, ladies and gentlemen, and get yourselves ready for that as it comes. Again, you may want to draw a wave on your sheet. You may want to label the parts of it because a lot of people struggled with those 4 parts to the waves that were on the questions that you had to ask. And by the way, ladies and gentlemen, I do appreciate you trying to give me an answer, but when you tell me that a chemical reaction is a reaction that is chemical, you are not getting credit for that. You got to come up with something better than that. And a nuclear reaction is one that goes through a nuclear process. No. All right. So, ladies and gentlemen, let's take a look at this for a minute. When a neutron splits into a proton and an electron, is that alpha decay, gamma decay, beta decay, or not a nuclear decay? Slide your cursor onto the one that you think it is, ladies and gentlemen. There we go.
So, Mr. Brand, how was basketball today?
Well, since nobody died, I think it was a good morning.
Nobody got hurt?
Nope.
Who do you play with? Like
Mr. Benstrom.
There's a group of teachers who play. Miss Kiefer plays.
what the frick? Sorry.
You didn't think she could play basketball?
No, I know she can play basketball. I'm looking at my test, and it said that I got the mass number wrong,
Yeah.
but it's right. And there's
Does it say?
It's a 0 out of 1.
Okay. I may have to go back and check yours then because I had the wrong answer in for that. So I will go back and I will check it and I will update your scores.
Okay.
Because I did find that in 5th hour. You're right. I had, for some reason, I put down 0 and it was not 0. It should have been like 138, something along those lines. Okay. All right. So when a neutron splits, I don't know which one this is up here, ladies and gentlemen. Not quite sure which one that is. Okay. When a neutron splits into a proton and an electron, that is beta decay. Okay. That is the beta decay. Okay. No change in the mass number of the atom because you lose a neutron, but you gain a proton. No change in, or a one more proton than there was before. So your atom becomes one bigger on the periodic table. The type of decay that produces a positively charged particle. The type of decay that produces a positively charged particle is which one, ladies and gentlemen? Which one produces a positively charged particle? And again, this was all in a summary table at the end of the slides the other day where we put it all in one place for you. Okay, good. A lot of them on alpha decay because that's what it was. Okay. Alpha decay, remember, it creates a helium atom, 2 protons and 2 neutrons that goes off, does not take any electrons with it right away, ladies and gentlemen. So that is an alpha decay. The type of decay that produces no change to the original atom. The type of decay that produces no change to the original atom, ladies and gentlemen. Which one is that?
You said you didn't grade the quizzes yet?
I did grade the quizzes. I even handed them back to you, but I do need to go back and correct one of the questions because one of the questions had a wrong answer in the key, and it was one of the ones that I had to grade. So, and it was one that a lot of you had right, if I remember. I didn't realize it when I graded it.
On my test, it says that I got the name wrong.
Did you put the name with the number after it?
That makes sense.
That's what. Okay. So the type of decay that produces no change in the original atom is gamma decay, ladies and gentlemen. That is gamma decay. Okay? The type of decay that produces an electron that is shot out of the nucleus of an atom. Which one produces an electron that gets ejected or emitted or gets shot out of the nucleus of the atom, ladies and gentlemen? Which one is that? It is a type of decay. It is beta decay, ladies and gentlemen. Beta decay is the one where an electron gets shot out of the nucleus. It is the one where a neutron breaks down into a proton and an electron. But the electron is in the nucleus, so it goes firing out of there. Okay? The type of decay that produces a helium ion. A helium ion. Okay. Correct answer is alpha decay, ladies and gentlemen. Alpha decay produces a helium ion. And that's it for the pair deck. Questions? Okay. So now, ladies and gentlemen, open up the assignment in Google Classroom that says Types of Nuclear Decay Worksheet. Please open that up. That is this one here, ladies and gentlemen. And you look, and there are a lot of names that don't have anything on it. And there's some names that aren't even on here. By the way, there are 3 sheets here. So some of you missed that too. Okay? Most of you missed that. So there is a link on the very first page, ladies and gentlemen. And I am going to get rid of one of these to make it so that everything fits on one page. Okay? All right. This link, ladies and gentlemen, takes you to a periodic table. And it's set for isotopes. So you can select any atom you want. And you're looking for ones that have this yellowish orange or more orangish box around them. That substance undergoes alpha decay. So this is the name and the mass number that you would write down on that sheet, because this one undergoes alpha decay. So this would be thallium-177. And please don't forget the 177. Now, again, some of you are choosing to write this symbol like this. That's fine. I don't care. Okay, you can do that. Okay, so, but you need to find me one that undergoes alpha decay. Then you need to find me one that undergoes beta decay. So for the beta decay, ladies and gentlemen, you're looking for one that has a blue colored box around it. And this one does not. So I'm going to go to a different one.
Can you pick the same one for
If
all
it,
of them?
well, the same one will, if it undergoes one kind of decay, it's not going to undergo another. But another isotope of it might. Okay? So another isotope of it might undergo a different kind of decay. That would be fine. Okay? But it's not going to, the same exact isotope will not undergo alpha and beta decay. It does not work that way. So you have to look around and you have to find an element, ladies and gentlemen, that undergoes that type of decay that we're looking for. So again, here I've got one that's outlined in blue. That is a beta decay. Okay? That will go on the second sheet, ladies and gentlemen. Hang on one second, please. Got it? Thank you very much. Okay? Jennifer, we're going to go take the quiz from yesterday right away. Okay? All right. And then, ladies and gentlemen, you need to find one that has a black box around it, because that means that it is stable. So those are the 3 pages that you have to get done. Just one on each of the 3 pages. If you cannot find the product of the decay, that is fine. We'll show you how to do that in a minute. But you should be able to find the isotope that undergoes alpha, one that undergoes beta, and one that undergoes no decay or is stable. So take about 5 minutes, ladies and gentlemen, and let's get this done. Okay? While we're doing that, I'm going to get Jennifer set up next door. Gentlemen, I hope you got this done because you're doing an awful lot of talking and not a lot of listening this morning. Okay, well, still, let's try not to disturb the other people around you who may want to listen. Okay? So do you have your periodic table, Jennifer? And I got this for you.
If it's stable in so we
If it's stable, it will have a black box around it.
and then we put like that element, the same element twice.
No, because there's nothing in there's one less column there. It doesn't say what the product is because it doesn't decay. So the third table, Zoe,
It becomes the regular, that one.
the third table doesn't have what it becomes because it's stable. Okay? Stable, no decay means it's not going to decay. That means there's nothing it's going to create. Victoria.
Something about so for this one,
We'll show you how to get that.
Like if you don't
We'll show you how to get that. That's what we're gonna work on.
That's fine. Just find the ones that have the decay.
That's what we're gonna teach you.
Okay.
Okay, that's what we're gonna teach you.
wait, so
I didn't go far. What's up?
What did you say that?
No, you just put the name.
I think.
Yes.
If it starts with decay and then it ends in no decay, like it starts with a decay and then there's no decay.
What do you mean it starts with a decay
And
then?
it starts with purple, it starts with
Well, remember, every one of those, Zoe,
and then it goes to black.
every one of those is a different isotope. So it's a different kind of atom. Each different kind of atom could do a different thing.
Right, it starts with it and then it goes to purple,
But-
purple and then black.
What I'm saying is it all depends on what the isotopes are. Some of them will decay, some of them won't decay, some of them will go through a different kind of decay. There is no pattern if you're looking for a pattern. It just depends on the element.
No matter what, if it ends in no decay,
It's not that it ends in no decay zone. What it's saying is that last isotope, the last one, just doesn't undergo a decay. Okay?
right.
So when you look at them and they're all stared out like that, those are all the same element. But they are different mass numbers. They are isotopes of each other. So the last one doesn't always do the same thing. Okay? The last one doesn't always do the same thing. The number at the end is the mass number. The number that is on top of your symbol, yes.
Then you're gonna follow it. See which one.
So Mariana, this can't be. 79 is the atomic number. You need to find the number above. Okay? The same way with, yeah.
That one doesn't do it. I mean, that one would be, like, this last one would be stable. That could go for the last one. 94. 94, 95. So those are stable. So that would go for the third sheet. Yeah. To go to the homework sheet. To go all the way down to the third page. You were so.
So on there, that one would work for there.
When this.
Oh.
So yeah. So that would be that. Molly Ben don't dash 94. There you go. And then it would be stable. Yeah. You know, and then we go find a different one that has one of the decays.
Miss Brennan? Yes. Yep. Bye. Lucy, you need to go down to the career center, please. Christopher, are you gonna get this done? Well, I'm looking at your name and there's nothing by it.
So click on one of the ones that does beta
So-
decay, and then put that one under the beta decay table. Beta's blue.
Okay, so when you look at these,
It's sort of like alpha decay too.
yes. That's how we do it, okay? We'll show you how to get that in a second, okay? So then, for the next page, you're looking for one with a blue box around it because that will be beta decay. And then you're looking for one with a black box around it because that will mean it's stable. Okay?
Just put beta in the left.
Now,
Because he's gonna go over how to do that in a minute.
Yep.
yeah.
Okay, so now let's go find a alpha decay one. That would be a yellow box.
Wouldn't I be right with my answer here?
Well, what's your answer
For
here?
my alpha decay,
No.
the first one I
Hold
know.
on. So here's Rutherfordium.
-2. 104 minus 2.
Becomes what? No belly.
Right.
No belly. Correct. But
And then go to.
your number after the is not correct. We'll show you how to get that. All right. Please listen, ladies and gentlemen. Okay? Now, again, I was kind of explaining this with Zoe, but I want to make sure you understand. There is not a pattern here. What I mean by that is each of these atoms, each of these elements has a certain amount of isotopes. And some of those isotopes may go under any one of these things. Now, we didn't talk about neutron emission. We did not talk about spontaneous fission or proton emission. We're not covering those things. We're keeping it kind of simple. Alpha, beta, and gamma decay. Okay? So when you click on an element and you look and you get all of these different ones, what we're looking for is one that has a black box around it because that would be stable. One that has a yellow or orangish box around it because that would be an alpha decay, and one that has a blue box around it because that would be beta decay. Now, if you look at hydrogen, hydrogen does not undergo alpha decay, and we said why the other day. Why does hydrogen not undergo alpha decay?
Only one on the periodic table that cannot go under it because it's the first element on a periodic table.
To undergo alpha decay, you need to lose 2 protons. Hydrogen cannot do that because it only has 1. So hydrogen will never undergo alpha decay because if it did, it literally would have to get a proton from some other atom. So it can't possibly do it. It can, however, undergo beta decay. Now, here's the other thing, ladies and gentlemen. again, there is no pattern here. There is no yellow one here. Even if you pick an element in the middle, let's go manganese. Okay? When you look at all of these for manganese, there is no yellow one. There are blue ones, lots of them over here. That just means that these isotopes, these different kinds of manganese, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, and 67. All of those undergo beta decay. All of them. Not a single one of these undergoes alpha decay. Why? Because that's just what it does. Scientists can't explain it, but that's the properties of it. It will undergo beta decay, will not undergo alpha decay. So sometimes you'll pick an element, you'll be like, okay, here's my alpha decay. Now I need a beta. It may not undergo it. You may need to find a different element. Okay? Now also, if you look at these though, ladies and gentlemen, there's a black one, so that's stable. There's some other ones, electron capture and things like this that we didn't talk about. But you're not going to find an alpha decay, so you got to move to another element and see if you can find it there. And you may not find it in the first few elements. Who knows? It all depends on what the element is. But they only break down certain ways. Kind of like, why are some elements corrosive or some compounds corrosive and some not? That's just their properties. So because of their properties, they react or they behave a certain way. Okay? Now, let's take a look at, I need an element that undergoes alpha decay.
The one I was doing.
Nope. I'm finding one on my own. Okay, I got a beta decay here. Hang on. Oxygen 25.
Can it for alpha decay like the any number be like the same?
What?
Can like element whatever number and then element whatever number, can it be like the same?
Okay. First of all, please remember, every atom that we are talking about here is unique and different. Even if it is two atoms of bismuth, they are a little bit different because they have different numbers of neutrons in their nucleus. And again, as I explained to Zoe earlier, just so that we're all clear, the same atom cannot undergo alpha decay and also another type of decay. They only undergo one type of decay. They either undergo alpha or beta, but the same atom cannot undergo both. Okay? So, I found an element, ladies and gentlemen, that undergoes alpha decay. That element is bismuth. Oops, what the heck am I writing over there for? Bismuth 187. Now, that is Bi 187, and bismuth is number 83 on the periodic table. Now, first of all, when you undergo alpha decay, you are going to create a helium atom. That is what you are going to create. This is the alpha decay, or the alpha particle. Now, because it is alpha, what happens is bismuth is going to go 2 back on the periodic table. So bismuth is normally 83, so 81 is thallium. So the way you're going to find, ladies and gentlemen, what goes in this column right, oops, I got to find the right sheet for you. What goes in this column right here under the product of an alpha decay, this element needs to be 2 behind or 2 to the left of the element that you found on the periodic table. So Rutherfordium is number 82, or I'm sorry, 104. 2 back is 102 nobelium. Now, the one thing we do need to do is you need to also account for this, ladies and gentlemen. the atomic mass of 4 is going to go away too. So this 187 becomes 183. So the element that you create is 2 behind the one that you originally had, and the mass number goes down by 4. So that's how you write the element that it creates. Okay? That's how you write the element that it creates.
Mr. Brand, I found one that has beta and alpha.
Not the same element though, correct?
It is the same.
Not the same
Lead.
isotope.
Not the same isotope.
Lead does. Oh.
That's what I mean. You may find it correct. I might have been saying it incorrectly. It is possible that one element could undergo alpha and beta decay somewhere in its isotopes. But one isotope. So in other words, bismuth 187 always only undergoes alpha decay. There is no other kind of decay that it undergoes. Another isotope of bismuth might undergo beta decay. You are correct. Okay? You are correct. So, the way you are finding what is produced, take this and go back 2 places and write the name of the element that is 2 places behind it. And then take the number that you wrote here and subtract 4 from it. That will get your alpha decay. Please do that real quick. So whatever number you wrote after your name, subtract 4 for the element that is 2 behind it.
So now beta is going to be 2 in front of it.
Hold on, we'll get there. Not yet, but you're not quite right.
So I have to switch my report on here. Go back. 19 or away from 253.
All right. Okay.
I'm good.
So this, again, please remember, ladies and gentlemen, this is alpha decay. Questions? All right. Now, for beta decay is different, ladies and gentlemen. So the element I have for beta decay is oxygen 25. Okay? For beta decay, you are going to move forward 1. So oxygen, if you move forward 1, it becomes fluorine. And for the number, there is no change. So for beta decay, ladies and gentlemen, all we do is move forward 1 element, and we do not change the number that is after it. We leave it the same. All right. Questions? All right. So a couple of you got to still finish moving. Remember, back 2 for the name, minus 4 for the number for alpha decay. For beta decay, you just move forward 1 and the numbers are the same, ladies and gentlemen. Okay? Now, you'll notice for stable, we didn't have to put anything. Why?
Because it don't undergo a second.
Yeah, when you're talking about something being stable, that means it does not undergo a decay at all. It stays the way it is, and there are lots of isotopes on the periodic table that do not break down, that just stay the same. Questions? Yes. Thank you. All right. Okay, questions at all about this? Okay, now this is a little bit harder to do with names. Okay, because names don't give you all of the information that you need. Okay, so when we do these decays, ladies and gentlemen, we're not going to do them with names. We're going to do them with symbols. And here's why, ladies and gentlemen. Okay, so let's take something that undergoes alpha decay. Radium-222. Okay, so I'm on slide number 28 in your EISN, in your notes. Please get to it. Okay, that's where we are at right now, ladies and gentlemen. And again, may be wise to keep your periodic table handy because we're going to be writing new elements from the old ones that undergo different kinds of decay, and you're going to need to look up the symbol on your periodic table. Okay, so radium-222 undergoes alpha decay. It gives off an alpha particle. The question is, what's left over afterwards? Well, here's the thing. The law of conservation of mass still exists. What I mean by that is, even though the atom is breaking apart and becoming a new atom, we still need to account for all of the things that were in it to begin with. So, for example, there were 88 protons to begin with. We need to account for 88 protons on this side. There was a mass of 222. We need to account for a mass of 222 on this side. The question is, what ends up here after you go through this decay? So, what we're going to do, ladies and gentlemen, is we're going to take our mass number 222 minus 4 equals what? (218). Then we're going to take our atomic number, which is 82, minus the 2 that are here. What's left to go here? What? What did I say? I'm sorry. Yes. Thank you. I'm sorry. 88 minus 2 will give us 86. So now that we know that it's 86, ladies and gentlemen, we can find the symbol based on that. And I'm sorry, I thought it would come up better, but it's not going to. Okay. So here's what we have created so far. Sorry. So up on the top here, we've got 118. On the bottom here, we have 86. These numbers we get just from doing the math. This number minus this number equals this number. The same on the bottom. This number minus this number equals this number. Now here's the question. What element is 86 on the periodic table? Which is Rn. So that's how we get our symbol here, ladies and gentlemen. That's how we get our answer. Questions? So we have to account for all of the mass even after a nuclear reaction. We have to account for all of the protons even after a nuclear reaction. Yes, go ahead.
Isn't it 218?
I shouldn't have taken the day off yesterday. Apparently my brain went south with it. Thank you. Yes. Thank you. 218. Sorry. Good catch. Okay, you guys tell me. What number goes on the top here? Good. Your math is better than mine. What number goes on the bottom here?
90.
Okay, so what's element 90? TH. Now again, when you're looking at the periodic table, ladies and gentlemen, the periodic table is arranged by what? By the atomic numbers.
Oh.
So when you find 92, okay, you're going to go back to that's going to be the element that you get. Okay? So again, this is in order by the atomic numbers down at the bottom. If you're looking for 218, you may not find it up here. There may not be any element that has a mass number of 218. So if that is what you are looking for, or if you're looking for 231, you are not going to find it necessarily on the periodic table.
So wouldn't you use the bottom number then?
That's what I'm saying. We always use the bottom number to determine what element this is. Always use the bottom.
And because doesn't the periodic table only go up to like 130?
118. 118. Thank you, Lucy. Okay, questions? Okay. Okay. So try this one. Tell me what you get. By the way, on your slide, the reason that I have this way is so that you can click on this 3x part and you can put a number in and it's already formatted for you. You can click on this double number part and you can put in a number there. It's already formatted for you as a superscript and a subscript. Then you can click on the XX and you can put in the symbol there. Okay? You can put in the symbol there. Okay? Are you ready to give me an answer, Ethan? All right, hang on 1 second here. All right, Ethan. What are we going to put on the top here? 236. What are we going to put on the bottom?
92.
All right, what's element 92? There you go, ladies and gentlemen. There is your answer. Questions? All right. Questions? Okay. So next, ladies and gentlemen, let's take a look at beta decays. Okay. Now, with the beta decay, we have a different symbol here. But the process that we're going to do is the same. Okay. Now, we got to be a little bit careful here. And I will explain what I mean. On the top, we still do what we did. 14 minus 0. What does that equal? Okay, so that's not going to change. That's the easy part of beta decay. But on the bottom, we have 6 minus a negative 1. No.
6.
No. Oh my gosh. If you are going to subtract a negative number, what do? No, you don't. You add the opposite, which is 7. Okay? 7. I know, it's weird. Why? Because you can, but technically, the way it is set up, this side has to equal this side. Okay? So to calculate this number, we take, on top, we take 14 minus 0. You guys did the last one, it was something minus 4. Well, here, you are taking 6 minus a negative 1 because then that actually means that a minus a negative number means you're adding that number. That's how we get it. Okay? That's how we get it. That's just the mathematics behind it. Okay?
So plus 1 is okay.
Yeah, if you think of it that way, absolutely fine. Okay, what element is this? Nitrogen. N, nitrogen. Very good. Okay. All right, so let's try this next one here, ladies and gentlemen. 228 minus 0. 228. You guys are going to love beta decay for finding the mass number. 88 minus a negative 1. Or as Kayana would say, 88, what, Kayana? 88 minus a negative 1. Or as you would say?
Plus 1. 89.
Okay, 89.
Yeah, that seems way easier.
It is way easier, but again, I'm just giving it to you based on the formula. If you understand that beta decay means you add 1, go for it. You got to understand that though. Okay, what's element 89 on the periodic table? Actinium, AC. Questions, ladies and gentlemen? All right. So here we go, ladies and gentlemen. Let me clear this. All right. So
7 and then 5
7 where?
on the top,
7 on the top. What on the bottom?
5 on the bottom.
Because 7 minus 0 is 7. 4 minus a negative 1, or as Keanu would say, 4 plus 1 is 5. What element? Boron. B. Thank you. Here, I'll take the calculator. Thank you very much. Questions? That's beta decay, ladies and gentlemen. All right, are you ready for the difficult one? Okay. Here we go. Difficult one, ladies and gentlemen. Gamma decay. Okay. 3 minus 0 is? 2 minus 0 is? So, what do we got? Got to be more specific. What goes where?
Oh, 3 on top, 2 on bottom.
And then BE.
No,
HE.
it doesn't change. Gamma decay, nothing changes.
Nice.
The one you begin with is the exact same one you end with.
Chemistry.
Still has 2 protons in the nucleus. It is still helium.
Shit, my bad.
During gamma decay, nothing changes. Nothing. So on the bottom, what do we got here? What's this one?
So top one's gonna be 60, and then the bottom one's gonna be 27.
Symbol? Don't look.
CO.
Don't look. It's right there.
Oh.
Cobalt.
Doesn't change. Whatever element you're given, that is the exact same element that you end with, ladies and gentlemen. Whatever one you are given at the beginning, that's the exact same one you end with. Questions?
Gotcha.
Okay. What do you get?
87 on top.
Hold on.
Oh.
Christian, what do we get? What do we get? Yep. 87. What do we get on the bottom, Mariana? 38. What is the symbol, Zoe?
That's all.
There you go. It doesn't change. Doesn't change. Okay? Questions?
So for the ones for beta, will the oh, it does change. Okay.
What changes?
The symbol.
The symbol does change in beta. The symbol does change in alpha. They change in different ways. Alpha you go back to, beta you go forward 1. Okay? Questions? All right. Okay. So, complete the following nuclear decays by solving for the product that will be created or the type of decay that is missing. Then in the yellow box at the end, identify what type of decay was shown, alpha, beta, or gamma. Okay, so again, just what we were doing. Now this is formatted for you. The reason that I have it this way, ladies and gentlemen, is you do not have to go in and do any superscripts or any subscripts. All you have to do is click on these 3 number signs. And you can change them to whatever you want. When you type there, it will be formatted as a superscript for you. Then when you click on here, these will be formatted as a subscript for you. You don't have to do that. So you don't have to do control comma or control period to get into a superscript or a subscript mode. I have it for you. And then when you click on these two, it will type in a regular mode for you to put in your symbol. Okay? So that is why this is the way it is. Okay? But, ladies and gentlemen, there are a few down at the bottom that get a little trickier. Why? Because I tell you what is created. You have to figure out what type of decay it was. Okay? But please remember, this number here has to always equal the two numbers that are up here on this side, correct? So here, you've got 14. Here, you've got 10. 10 plus what number equals 14? So you put a 4 here. What plus 4 equals 6? 10 plus 4 equals 6. 2. Okay, so if this has a 4 on the top and a 2 on the bottom, what letters go in here?
Whatever, AG.
Good. There's only 3 types of decay. It is either going to look like this, or, I don't know if the one above it is that way. Yep, that. So when you're solving for this part here, which is the decay, it's either going to look like this, or this. That's what it's going to look like. And then you come over here and tell me what type of decay it was. What type of decay it was. Questions? All right, ladies and gentlemen, go to work on it. Go to work on it. You got about 15 minutes to get this done, ladies and gentlemen. If you have questions, I will be happy to answer them.
Mr. Brand, how do we make the gamma symbol?
Ooh, good question. Here's what I would do, and this is just me. I'd copy and paste. You have 2 choices. If you want to make a gamma symbol, ladies and gentlemen, let's say you want to make it here. You can do insert special character. And in this box, type in gamma, G-A-M-M-A. And it will give you symbols for gamma. The first one is the one that I would use. Okay? So you can put it in like that. Or you could simply go up to one of these, ladies and gentlemen, and you could copy it and paste it in there if you want. However you wish to do it. Okay? However you wish to do it, that is your choice. But that is what you have to do for the gamma. You either insert special character and type in gamma, or you have to copy and paste from up above. Your choice, ladies and gentlemen. Good question. Your choice.